Welcome to the technology space. In the technology space, so we will also discuss about in this topic learning Erlang programming language, concurrency and fault tolerance, processes and message. The basic unit of concurrency is Erlang is a process which is a lightweight thread of execution that runs independently and communicates with other processes through message passing process and created with the response functions which take a function as an arguments and return a process identifies PIT processes and can send and receive message using the send and receive operator which are asynchronous and non-blocking. Messages are created in the mailbox of each process and can be pattern matched to handle different cases. Fault tolerance and supervision. One of the key advantages to Erlang in its ability to handle failures gracefully without crashing the whole system. This is achieved by using the let it crash philosophy, which means a thread process and expect it to fail and be restarted by the process. Called supervisors. Supervisors are responsible for monitoring, restarting, and organizing their child processes according to a predicate points strategy. Supervisors can instead to form the supervisions tree which provides a hierarchical structures for fluid isolations and recovery. Erlang provides a standard library called OTP Event Telecoms Platforms that includes a set of generic behaviors and tools for implementing supervisors and other command patterns. Distributions and clustering. Another benefits of Erlang is its support for distributed programming, which means thread process can run on different nodes, machines, and communicate transparently. A node can be connected using the net kernels model, which provides functions for discovery, naming, and graphy nodes. Processes can send message to remote processing using the same syntax as local ones on by using the format PID at the red node. Erlang also provides machine mechanisms for distributing code and data across nodes, such as the global model for registering and access global names and the amnesia model for creating managing distributed database. Concurrency patterns and best practice. Designing and implements concurrent and distributed system which Erlang requires following some general principles and patterns to improve performance, scalability, and maintainability. Utilize functional programming techniques such as immutability, recursion, higher order functions, and pattern machining to avoid side effects, states, mutations, and complex control flow. should be used sparingly for independent and isolated tasks that requires concurrency.